Yeah, maybe we can discuss about upgrade workflow if you like. But I know it's pretty complicated one. And what do you think?
Yeah, I think that's a great idea. Give me 1 second just to make sure that we say the things that we're supposed to say before the recording fully goes off. But welcome to this morning's CapN call. This will be recorded and posted to YouTube, so don't say anything you don't want to be posted. And the recording already has started. If you want to add that to the agenda, just so that we can document that that's what we're actually, I can as well. Do you want to kick that conversation off?
Yeah. Do I need to type it? Okay. Let me add it. Let me add to the agenda first.
Sounds good.
Yeah.
Cool. And Charles as well. If I don't know if you have any, if you've had any time to spend on KCP, I'd be curious if you've dove into it more. If not, no worries.
Yeah, I took some time to dig into it, and I found for the Docker provider of the CAPI, because I refer a lot to the Docker provider. They use the machine, so they set up the kubeconfig on the machine CR, and then a Docker machine controller will use that CR to bootstrap the whole control plane. So I think we are now going to use the same mechanism, or because we do not have a machine in our case. So I'm still trying to figure out, are we going to use something to mimic the machine things, or we just use the kubeconfig control plane, kubeadmin control plane controller to just extract the configuration, kubeadmin config, and then use it to bootstrap our control plane components. Yeah, I'm still try on both way, try to see which one is better. Yeah, but for now, I think we should go with the second one. Maybe we should not mimic the machine CR in our case. Yeah, it makes things a little bit complicated because we do not have a machine. Yeah.
Okay, good to know. Cool. Yeah, at some point, we should continue to think about that and see what that would look like, and see if you need any help from anybody else to proof of concept on any of that.
Yeah.
Cool. All right.
And I will also clean up some of the code, because when I try to add a certificate manager support the flavor certificate manager, I found a lot of like duplicated code in the nested controller component. So I will try to clean up that part of code this week. Yeah.
Sweet. All right, Faye, you can get started on the upgrade story.
Yeah, before that, for the cert manager, I saw it change, but it's all about the YAML. So from the workflow perspective, so should we just install cert manager and apply the YAML, or is there anything else we need to take care in our?
So the certificate manager is based on the quick start Chris just made for. We assume that we are using a CAPI with the CAPN. So when we initialize the CAPI components, we are going to install the certificate manager. So in that case, certificate manager is already start. So we can just simply apply the YAML. And if the certificate manager is not there, the current implementation of CAPN will generate the certification by itself. So it will check if there is a certificate manager or certificate CR in the cluster. If not, the CAPN controller will generate the certificate and all the private key by itself.
Oh, the code is in? That check code is already in?
Yeah.
Okay.
That's Chris has already written that part. Yeah.
Okay, let me think about it. So yeah. Okay. So
this also allows you to support overriding it with anything. So like internally, we don't really use Cert Manager right now as much. And so we're able to at least create all the secrets that we possibly want at the right locations. And at the end of the day, if you look at the code under control plane nested, I think it's under certificates at the root of the control plane project. You'll see what it's actually doing. There's basically a function called lookup and then a function called lookup and save. And lookup just goes through and checks to see if a specific secret name is created, and it will load the certificates out of there. So if you don't want to use cert manager, you can override by using any cert. You can use the known good cert names for any of those, whether they're client certs or CAs, and just supply that, and then the control plane will use those to boot.
Yeah, I just want to make sure we actually documented as the way that we describe now. So let me check, because
I think I will update the quick start or some other documentation to make sure if user wanted to use certificate manager, it will get the right template. Because right now, since if you notice that I updated the templates directory, and how it works is the cluster CTL, when it generate the cluster, and it will specify the provider is Kaplan, and then it will retrieve the templates from the templates directory. And if you specify the flavor as certificate manager, it will retrieve the certificate manager related templates and use it to generate the whole Kaplan control plan. So I will update the quick start to make sure if user wanted to use certificate manager, it will run a correct command, cluster CTL generate command. Yeah.
There's one additional piece which I didn't add as feedback because we're not there fully yet. But once we get the virtual cluster, well, we have a virtual cluster flavor in there as well, which won't use cert manager out of the box. And so we're probably going to have a duplicate of that. That's like cert manager virtual cluster, and then just a virtual cluster one as well. Because right now, to deploy Kaplan with virtual cluster out of the box, you have your own that you could just use, and it just uses the in-tree certificate generation.
Yeah, but for the YAML, I was about to ask, why do you put the cluster the cluster CR as well? So I'm assuming it should be all about cert manager CRs. Why do you put cluster CR in that template as well?
So when you run a command, the cluster CTL generate, that will retrieve the complete templates from the template directory.
I see.
So yeah.
Maybe the naming is kind of a little bit confusing because template cert manager, I thought it's all about cert manager, but so you're saying that class CTL only supports one template, which should include everything.
Mm-hmm. Right, it's like all in one.
Okay, that makes more sense. Okay, so the naming, maybe we should think about make it more clear, or we should document it somewhere, because that's all my whole point. I'm not exactly sure our current documentation. Let me see. Did you change the README in the doc already? No, quick start.
I have not. No.
Okay.
Yeah, I will do it later. Yeah.
You probably change it more to reflect the change it for survey. Yeah. I think that's great. So because I believe more and more people will hit the situation, especially guys like they use OpenShift kind of thing, so they leverage a lot on the cert manager that is existing. Okay, that's great. We have that support. For the upgrade story, I don't have too much to say, but just Chris and we were last meeting. Chris was wondering how this should be upgraded. To me, I think the upgrade, they don't have to be everything, you stop your service, upgrade everything as a whole, and then resume the service. It doesn't have to be that way. But in my opinion, because of the backward compatibility, I'm assuming, although I have never seen, I don't, unless we have deprecate API, even we have deprecate API, we rarely remove API fields, right? Chris, just correct me if I'm wrong. So we rarely remove it. So then in general upgrade workflow should be, you just upgrade super cluster first. Supposedly you shouldn't break anything. If you upgrade,
I'm gonna add one note in here just to throw this out. Well, actually, I'll ask the question after. Continue.
Yeah, my assumption is because of backward compatibility, you upgrade the supercluster first. You apparently know what's the problem when you upgrade VC first. You have a new field, and that new field cannot be applied in the super. So that is pretty much the thing that we should try to avoid. you need to upgrade the super cluster first because of this reason anyway. And the Syncer version, as far as I can see, there's no strict order requirement. It can be higher. I mean, it can be higher than the super cluster, which is currently what we do already. It is higher, unless you don't. So the tricky thing is in the Syncer code, so just be careful about manipulate very specific fields. But I know it's really hard to conduct. So the recommendation then should be upgrade the super cluster first. But the problem is in our project we have no way to enforce the super cluster version. We can only enforce the Syncer's version as we did. Because in the Syncer we always upgrade our Syncer, bump up Kubernetes support to higher version. That's what we did in upstream. But I don't know if we have a way to enforce that, saying, I don't know if we should do that, saying that Syncer checks if the version is lower than current supported version, just doesn't boot it up, doesn't start Syncer. I'm not sure if we want to do that or not, because not everybody pick up the latest super cluster. I would say many people still use 116, I would say.
I would hope not. 116 is well out of date at this point. But yes, I agree. I think I think it would be interesting if we had some sort of checks that at least, if nothing else, put a little log line at the top when you started the Syncer that said something like, you're pretty far out of compatibility. Because that should be just an easy, like, is super out of, n-1 or n plus or minus 1 of current expected release in VC. I don't know how hard that check would be to do. I imagine not much, because it would just be loading up the client set and then saying, oh, what's the actual client version server version versus client version. It feels like it might be at least like a little bit of a usability thing that we could add just in case. Because if people are using 116 and they're about to move to this, they're about to get a world of hate, because that was the key release where there were so many deprecations, or like the next couple releases where V1 beta 1 for API extensions changed, like all of the like big changes happened in Kubernetes in that right around that same time frame. And so I don't know how that like there's a really lack of backwards compatibility there.
So another thing is the version comparison between the VC and the super. So that is more important than that. So in theory, because when we started the project about 2 years ago, it was we were testing 114 and the VC is 112. Super is 114, VC is 112. If I remember correctly, it's pretty old version, and apparently it still works. So so that's the thing. So I'm not exactly sure whether absolute checking on the super is necessary, or as you said, maybe we can give a warning. That's always, as we always said, saying that you're already 2 years behind, lagging behind the upstream, version. But because the upgrade super is much more complicated than updated virtual, because because super runs pods and its production environments, upgrading that cluster always has a lot of concerns. So, but the same, if you don't upgrade super, which limited your virtual version anyway, then we can have a strict check saying that if the virtual version is higher than the super, we shouldn't even allow it, because the syncing may cause a lot of problem. So, but I don't know. Again, I don't know how easy we can do that check as well.
Yeah, that one's another interesting one. I think I think both of them are really good checks. It seems like in the multi-cluster controller, we could probably do same sort of thing when it's loading up the client set, just pass it into a function that checks compatibility. And it just is I would assume it's just connecting. It's really just starting to check against Well, does it matter what the super is if the, like, this is where it gets weird because we have all of the conversion lifecycle from client Go built into the syncer. And so we do have a weird piece here where we can, like, VC could technically be above as long as the syncer, sorry, the tenant control plane could be above in the release version, I think. Correct me if I'm wrong here. If the VC version is within its scope to be able to handle conversions, and there's obviously no breaking changes, but if it's within the client version of, then maybe not, maybe I'm thinking wrong. I'm thinking that basically, like, when these things load up, it's going to go through the conversion, not webhooks, but the conversion hooks within all of client Go and try to parse into what it knows. And then what it knows needs to be in alignment with what the super is. And so it almost like parity between super and syncer needs to be the same, but virtual could potentially, as long as it's within that n plus or minus one, I think that might work.
No, the problem is okay. I'm not saying that it's crashing. It's probably not crashing.
Sure. Dropping fields and things like that, and not supporting features.
That's a problem.
I got you. Yeah. Okay.
Because people want to use the pod spread API, which is 120, and he specified in VC, and he see no spread happens in the super. How do you do this? There's no
that's a fair point.
Error message. There's no error message. Everything looks fantastic.
Yeah. Okay. I got where you're coming from. That makes a lot of sense. So the one question I wanted to add into that is something that we haven't fully worked out. And I'm curious if you experience this or see this, or just your upgrade strategies of your supers are so different that it doesn't matter. A question that I got asked earlier last week or the week before was, when you do upgrades, traditionally based on like Kubernetes documentation, it declares that you should be draining nodes to reprovision pods onto nodes. So when you upgrade a K node, you could basically go through, you would drain all of it, upgrade kubelet, so on and so forth, and you then have the new version of the kubelet. Obviously, at this point, your control plane in the super is supposed to be upgraded. Yeah. Because of that rollout strategy, that obviously affects the syncer in that the virtual cluster, or the tenant control plane, in that pod gets bounced and put onto a new node. When you then upgrade the control plane, do you in your own environments, do you see your pods bounce twice, or does it not matter?
No, I don't think we use that drain logic at all.
So you just upgrade in place.
We just upgrade in place in Kubernetes. We cannot afford drain in any form of cost. It's impossible.
Got it.
I think when you have cluster with 10,000 nodes, how can you prepare another 1,000? I know you can do rolling upgrade, right? So, but
sure,
it's very, very complicated. You need to have an application, not even tools. You need to have an application to do that.
Sure. Okay. All right. So that defines that a little bit more. That makes a lot more sense as to what you're doing there.
Yeah, it's control plane upgrade. It's not data plane upgrade. So if you need to upgrade the OS, you have no choice. If that upgrade needs restarts, you have no choice. Then you have that need to go through the calorie kind of upgrade process, like rolling upgrade one by one. That may take really long time, but everybody is aware of that, because the true infra team from everybody saying this machine needs to be restarted. And I believe they have a I don't know the details, but I believe they have. But to upgrade Kubernetes version, I don't think they go through this way, because Kubernetes can do in-place upgrading, if I remember.
Yeah, it definitely can. It all comes down to the componentry that you use as well. Like the strategy that I've heard is that you're supposed to do the documentation wise, at least from the Kate's docs, you're supposed to do the drain because there could be new fields added that aren't going to be automatically added and synced down to the kubelets if you don't drain those and allow them to re-kick. So in your example before, if you add pod spread to the control plane and you don't reprovision pods, how does that actually tier down to the actual workloads?
Oh, yeah. I totally understand about I don't, especially for the version. Okay, let's assume you are doing the draining. So let's assume that. So your problem is if people do draining, and so you're afraid that
I'm curious. I don't actually know. It's not a fear. It's more just I'm not sure what the right strategy should be there in terms of, so we upgrade supercluster first. Supercluster gets upgraded. We've drained all the hosts. That means that the pods now technically have new specs potentially if there's new fields added.
the current
Say, for instance, managed
current
fields or
workflow,
anything like that.
in current workflow would be the draining process will kill the V pods. And the
syncer is going to resync them down through and the pot and
it's not
through this.
It's not sync or resync. It's like the V controller need to create a new V pod because we delete a V pod.
Oh, right. Okay.
Because we delete a V pod, so everything is like it's like we delete a pod. Drains like you delete a pod, and we propagate that deletion up to the virtual cluster, and the virtual cluster controller will create a new pods and go through the rest of the thing. Because you condo that nodes already, so it's not going to be scheduled on that nodes.
Okay, yeah, that makes sense. And then once you've done that, once the control plane's been upgraded,
actually, yeah, a lot of things you need to think about it. So if you really do rolling upgrade, so think about a rolling upgrade case, right? So you supposedly to put all the drained pods to the new pods, new nodes. You shouldn't spread to any other pods, any other nodes, because the rest of the nodes needs to be upgraded anyway. You will create multiple times, so that's a really bad thing.
Yeah, that makes sense. And then, so really once you upgrade, because yeah, it should just be that the data plane is actually where it gets kicked, where all those pods get kicked and have to restart or have to reprovision to new nodes that have already been upgraded. But the control plane upgrade really shouldn't have anything to do with this, because I guess this is where it gets confusing. So if a new field got added to something and it gets synced through, and you've upgraded the supercluster's control plane, now you're upgrading the supercluster data plane. And once you've upgraded the supercluster data plane, there's potentially new fields that have been added to it. So in theory, because the syncer is working off the supercluster and off of the tenant control plane, when it does the syncing logic, that should pick up any changes in there that would make it out of sync from like a comparison perspective, what the actual equality checks that we do between those. So that would mean what I'm curious about is there ever a chance that we could get into a situation where the syncer expects there to be fields that it's not getting out of the tenant control plane because the tenant control plane has a different client version and the super has a different client version, and it's saying, hey, I don't have cluster IPs. And the tenant control plane says, yeah, I have no idea what cluster IPs are. This is a new field for me in services. Yeah. And now it's just going to constantly delete the service and try to recreate through that whole loop and just continue to, I'm curious if we could ever get into a situation where that could cause us any problems. Yeah.
As I said, so for the syncer, I don't worry too much, because think about it. You should, let me think about it. So because the syncer client Go version has been bumped up to the higher anyway, right? Syncer, yep. we'll use that client to access virtual. So that client Go should already have that latest field anyway. You shouldn't, because it's kind of, I'm using a higher client to access a lower version Kubernetes. Because of backward compatibilities, it should work, but they will fill that fields with empty things. So you just don't grab anything. If I understand the design correctly, it's like you use a higher version client Go to access a lower version.
Yeah. It'll inject those fields for you. You're absolutely right. And our equality, I guess, shouldn't matter at that point, because it's not going to, because it's just going to see.
The only dangerous thing is to write. If you write something to the virtual cluster, then you are supposed to using higher API version to write the object to a lower, to a API server that support a lower version. That can have error, if I understand correctly. Or you are saying that client Go also will do the conversion? Probably.
Client Go will do some conversion in its implementation. It'll try and set the right versions and do defaults and stuff like that for you.
So they will drop the extra fields?
That one, I'm not sure. The extra fields, I'm not sure if it's going to drop them. I'm not sure how that'll actually function. I mean, in this exact example, in the cluster IPs example that Vincent just added, that one's a weird case, because in out in an in-tree upstream version of this, where you don't have highly customized network stack that manages the cluster IPs at the tenant control plane. That one's gonna be weird because cluster IPs, the actual like plural field for this for services for dual stack, gets added at the supercluster. And so we're going to get into this weird area where the supercluster wrote a field and tries to sync it back through, or potentially doesn't sync it back through. I don't know how that's going.
Yeah. So in current implementation, we just drop that field. They're not going to be synced back anyway. But do you think we should think about it? We should think back? That's
I mean, it's the same thing as cluster IP, so no.
Yeah.
But we do need to figure out what we're going to do about, like, we do have, like, this is a dual stack in general is a feature that I think we need to have somebody that spends some time and thinks about what this is fully going to look like, because we have the annotation for this real supercluster cluster IP added as an annotation to all of those services. We need to think about what that's going to look like for cluster IPs, because cluster IP only represents the 0 indexed cluster IPs that are defined in the way that it's set up. And then the secondary could be associated with anything. It could technically be, it could be like a routable one within the supercluster or within the tenant and the supercluster. It could not be. There's a lot of pieces there that are probably dependent on the implementation that people run, but also what we're going to, how we're going to handle that. Like, if you have a dual stack supercluster, do we need to sync any of that data back up properly for you? Or can we just throw it in an annotation and make the annotation like comma delimited now instead?
Sure. Chris, just remind me, how do you guys, I know we have this discussion a long time back. How do you guys resolve that class IP problem?
Proxy. Right now. Yeah. Right now in the interim for like changing our network stack entirely to support this, we do a proxy of the services cluster IP. So we don't actually run the in-tree service syncer. We have a fork of it that's in our custom syncer, and that runs and goes and does. We don't do anything in the syncer. We have a webhook that's added into a mutating webhook that's added into every tenant control plane. When a service comes in, we hit the supercluster. We create the service based on the same exact scheme that we use and all of the conversion functions out of the syncer, and then grab the cluster IP from that supercluster, sync that back in through the mutating webhook, store it in the tenant control plane. And so we have very, very flat networking at that point.
Sure. So I don't know exactly how that class IP is generated. Is it in the same workflow or different?
Supercluster. Yep. So we generated the supercluster and sync that attribute. Well, right now we don't, because we didn't have the fields actually in here. But yes, that in theory would be synced back up the same way that the supercluster does. We keep the cluster IP annotation in just to make sure that if we were to ever switch back to the full running of the syncer service resource, that actual code, that package, going back to that there's no conflicts with the equality checks as well.
Okay. So the class IPs is also, is added by the controller. So it's like, how should I say it? It should be same workflow as setting class IP. Basically, class IPs and the class IP, they are going through the same workflow to set both fields.
Yep. Yeah, it's a weird use case. I mean, that's something that's for us specifically. Like, that's something we're obviously going to change eventually, because we want to put the onus on the tenant control plane so we can distribute that. We thought about other ways of how we could do this user space. Could we actually? I need to look into some of the without having to change the underlying network stack, which is I think what a lot of people from the open source side of things would be doing. How do we actually do this at the user space level? Do you inject sidecar pods that actually support routing service cluster IPs so that you can run that at the user space level as sidecars to create those additional, like I've been trying to figure out how we do this upstream so that somebody deploying this off the shelf actually has a workable cluster or a fully workable cluster, meaning the network stack actually works and the pods schedule properly. And I don't know much about those yet, but that's something that we've been kind of talking about and noodling.
Yeah, I think the offscripts, as I said, told you before. So just correct me if I'm wrong. So the class IPs is just because we want to have an IPv6 version of class IP. So that's the reason we introduced it. This is
yeah, so dual stacking. So you can have, so what you typically have in that setup is you have one IPv4, and you actually have a bunch of new fields. I should have commented on that on Vincent's pull request. There's two pieces that were added. There was cluster IPs, the plural, which always has, like, there's some validation there that says the zero index, how it has to be equal to the cluster IP field, which is still considered the primary, the primary interface for it. And then there's an additional field that was IP families. So there's IP family always on there, and it's the same sort of validation that the zero index of IP families needs to be equal to that. And that's typically where it says IP1 or 0 is V4 and 1 is V6. And so there's actually another field that we need to add into that. So I'll see if I can poke Vincent and see if he's able to do that.
That's kind of, it's a little bit, okay. I don't know how to, so to me, it's kind of a little bit weird designs saying that you have an internal system, keep updating the spec.
Yeah.
So that's kind of anti-intuitive. So the rest of the Kubernetes services rarely does that, right? So the spec is specified by people, and anything that the system does should apply to status or something like that.
Yeah, it's more just the defaulting that they add into it. I mean, it's kind of like how you have this is where we get into the weird differences between Kubernetes being truly declarative and not being truly declarative.
Yeah.
Right? You basically have, like, okay, we're going to inject a service account name into every one of your pods. And you're like, but I didn't specify that. Hold on. Why are you setting it to default? Like, that's not what I asked for. And it's the same sort of thing here. It's going, okay, we're going to be a little bit intelligent and try to assume what we know based on the superclusters topology to set things.
Yeah, just correct. So just correct me if I'm wrong. So for class IP, I know it's API server conduct with the NCB to get that IP for the uniqueness. Is IPv6 going through the same route, or okay?
Yep. Yeah, there's like a /64 that's added to, if I'm not mistaken, for services. Yeah, I think you could you can specify as well through flags. So basically, like the service cluster CIDR range, you can specify that. And so we run our tenant control planes with dual stack and our superclusters with dual stack as well. And so we do the exact same syncing between the two. I actually remember I did.
I understand people hard code the class IP, but really no one can hard code IPv6 IP, right? It's impossible. Oh, I mean, it's possible, but it's like crazy. You remember that.
Yeah. Dual stacking is a fun world to get into.
Okay. Yeah, so there's always problems. So I don't know. So in our current model, so we will have a problem like this. So luckily we only have service has this problem. If there are so many API objects, they need to change the spec. It's not even human user noticeable way of changing. It's like system automatically mutate the spec. So
you can set those fields yourself. You can definitely set those fields yourself.
That's what I'm saying.
Yeah.
For IPv6, is almost nobody is going to set it. I mean, class IP is maybe okay because it's traditional full numbers. You can think about it because how you cut off your network subnet. You probably can do that manually. But for IPv6, I'm going to do that manually.
Oh, come on, Faye. You don't sit around writing 128-bit IPs all the time. That's what we're supposed to be doing. That's what it means to be a software. Just kidding. Sorry. Just being snarky over here. Yeah, no, agreed. I mean, it's definitely going to be a harder thing for people to be doing out of the box. More so just from the visibility side of things for your clusters and figuring out. I mean, there's a lot of other kinks that we still need to work out from the Kubernetes side of things on how this works. Like, how does a dual stack service, if you have one dual stack, one of the IPs that's actually routable and one that's not, that kind of breaks Kubernetes policies, but it's technically still supported. But you get into a weird place where you have to have your v4 is routable, or sorry, not that you have to have your v4 routable. You have to have your primary, meaning cluster IP has to always be routable within the cluster. The secondary technically isn't always used, which gets you into a weird place where if you want to, you can't use the secondary right now for things like health probes. So Kubelet won't actually use the secondary IP if you want it, even if you wanted it to. And there's no way to get the secondary IPs specified in like, there's an open issue that I was reading about how you can't get them into the into like the health probes to set up that, or the downward API as well. But those are bigger pieces that Kubernetes has to solve too.
Sure. Just one more question. So for the first primary and secondary, they cannot be the same time. They have to be one IPv6 or can you have two IPv4 class IPs? Are we going to support that?
I think there's validations against it. I'm blanking. I know I looked this up a lot earlier this year.
Okay.
I can get back to you on that though.
Yeah,
The spec for services has it all documented in like the type fields for cluster. Here, I'll just look it up while we talk. I'll get back to you. That doesn't mean we have to stop the conversation.
Yeah. Okay. So yeah, I see.
Also, we just had somebody join a little bit ago, and I didn't get a chance to take a break. Armin, do you want to introduce yourself?
Hello, can you hear me?
Yeah, absolutely. Welcome.
My name is okay, thanks. My name is Arman Absalan. I'm software engineer at Coffee Bazaar, Iran. I'm interested in Kubernetes. I'm an infrastructure engineer, junior infrastructure engineer in Coffee Bazaar. I work on KubeVirt and some stuff. I'm very interested about your meetings. I randomly click on one meetings and I'm here now.
Awesome. Well, welcome. Glad to have you. If there's anything, if there's any major questions you want to bring up, we're just kind of spitballing about cluster upgrades and what this is going to look like for our setup. But if you have any overarching questions or anything like that, don't hesitate to ask. You can either just raise your hand in Zoom or you can just unmute and ask questions. We're pretty open about that, but we're excited to have you.
Okay, thank you.
So in answer to your question about about can they be, it appears that the actual feature gate, which I guess is where I forgot about this, is the feature is IPv6 dual stack. So no. So you only have v4 and v6. You don't have both, or you can only have both. You can't have two v4s for it. When I was originally looking at this problem earlier this year, because before we implemented the proxy path, I was actually trying to overload the cluster IPs field to make it so that the first one was routable. The second one could be from a different range. Like you could add multiple into it because it's just a slice. Because I thought, oh great, we can add a bunch of network interfaces to our pods and now have this. I mean, you'd have to run a custom CNI. We all know to do this thing anyways, you have to have a custom CNI. But in theory, you could go that path of having multiple ranges that you're associated with and have dedicated virtual cluster networks, super cluster networks, so on and so forth. But yeah, they made the validations a little bit too strict to be able to enable that.
So Kubernetes does the validation or API server or both? I think both.
API server.
API server. Okay.
Yeah.
Okay, that's fine. Yeah, it seems like our hardest problem is always coming from the service. So other than that, seems okay.
Now, I think I've sent this out before, but there's also a KEP that's probably important for you to read if you haven't already. There's a KEP that's in, I think it's still a provisional state, but there's a whole thing written about an API for the allocation of cluster IPs and of node ports, which is kind of an interesting thought process. where I think in your world, you're doing it a little different since you let the tenant control plane be the actual arbiter of the owner of the cluster IPs, which I think is the real right path to do.
Yeah.
There is this new strategy that I think, I'm not sure who is actually spearheading it, but the idea was to create a new public API where right now IPs are allocated deep inside of the registry code base for Kubernetes. The secondary piece, or this KEP, was basically saying that we wanted to create a new public API that you could then go and do allocation and deallocation, very much like a traditional IPAM, of IPs from the ranges that are known about from the supercluster, which I thought was kind of intriguing. And their goals behind it were scalability of the superclusters to be able to expand beyond the default CIDR ranges, and having an external API that you could then, in theory, the way that I've kind of, from reading the KEP a couple times, thought about being able to use it if it gets implemented, is our proxy path could, in theory, just use that allocation API instead of having to create a service. Because right now we have to deal with what happens if you orphan a service, or what happens if your validation fails in the tenant control plane even after you created it in the supercluster, and you end up with those orphans. So we've had some weird.
So are you saying
things
that
we have to deal with?
So are you saying that is this KEPI project?
No, it's a Kubernetes KEP. I'll pull it up for you, or
Okay.
I'll drop it into. I'm gonna drop it into.
That's kind of interesting.
Docs.
So you are essentially saying that we should bypass the IP allocation that down beneath the LCD kind of thing, and we should use a like IPAM kind of controller to do explicit IP management, and for every service we should fill the class IP by ourselves, by the controller, not by the API server.
I wouldn't say we have to do this. I'm more talking about things that we were looking into potentially solving our problem, which would solve the upstream problem as well. Because no matter what, we're still going to have that as how do we solve it for somebody just using this whole code base off the shelf? Because I
want to take a look. So you are saying that, so then the super and the virtual, they need to they both need to access that, right? They need to do the coordination.
Yep. I just dropped it into the Google Doc so that if you ever come back to it, or if you don't want to look at it right now, but it's in the Google Doc. I just added the cluster IP allocation KEP, which is kind of interesting. And they're trying to work out a scalability side of things so that they could actually make it so that each of the control plane nodes sets up specific sets of the range, so that one API server handles some set of the block and another handles another set of the block, and it internally load balances across them. So they have like a new IP request resource that you could go and use to get a new IP address. It's pretty interesting. I would check it out just as this might affect us later. I don't know if it really will. Again, I think it's still in a provisional state, so I'm not. I mean, you can see the whip tag at the top.
So for the API perspective, it's going to be, I'm assuming it's going to be a new API resource, does it? That'll be interesting. Now things get, okay, now I understand.
Yeah.
You actually bring up a good question. So, yeah, I haven't thought about it, but another thing is if our Thinker gradually supports more and more building API resource, that affects our upgrade. But again,
yeah, this is where the upgrade strategy then gets affected by anything we're trying to do. Like those, it's the world of that we're trying to avoid, which is these superclusters become really they're pets at that point, and you don't want to do anything because they're now owning resources where in your world they're not owning resources, and so you're trying to avoid that as much as you possibly can.
So I was thinking mostly is like we keep our Thinker, so the Thinker the existing. I don't know, so we need to think about it more. So because the whole point is we trying to make sure all the objects that is needed by the pod provision we think all rows objects. But what if there's one more dependency, there's a new type of object which is part of the pod creation, if the product creation depends on new API objects, how that would be that'd be a big problem. You mute yourself.
I am muted. Thank you for catching that. Yeah, that would be a big, if there's new pieces injected. I mean, those are just things that we're just gonna have to deal with. It's just gonna be, okay, we know the client and server versions for this. We can check to see those things. Luckily, we're gonna have a long time before this really happens. I mean, we got to think about the Kubernetes release versions and what the life cycle looks like.
Yeah, for the upgrade parts, if that really happens, I'm afraid we have to upgrade everything.
Yeah, everything has to go at the same time, and you have a really like a big breaking change across. I mean, no, we could do it because the syncer would be able to handle. So, just throwing out the case. So in the world, okay, now you have an IP resource. Not that this is how it's implemented. When you read the KEP, you'll see that it's a little bit different than that. You don't technically have to have an IP resource and a service separate. The service could underlying use the IP resource to go and issue itself an IP address. And so you wouldn't have to create 2 CRs to get the same functionality we get out of one, but you'd be able to, so like out of the box, services would still work just like they do today. The addition is that we would be able to, out of tree, request an IP address that falls into the same range, meaning it's now routable. Yeah. But if there was ever the case, like what you're saying, like to deploy a pod, you now have to have this additional resource to it. We have the syncer in place, so we could always just create those resources for the tenant, and then we just manage it, and we just keep a check of, is it this version? Does it support this resource? Okay, great. Create that with it, and it's not fun, but at least it would work, and we could transparently set that up for tenants. I think if that's what you're getting at.
Yeah, let me think about it. It's all about what kind of data resource can sync actually defaulting it. That's the key. Your syncer cannot default it. It's part of the work. It's part of the workload. So syncer cannot default a workload. So then you have to. But I'm afraid that would be a very breaking change for, not even for hours. It's like the entire Kubernetes client side, all the controller needs to change that. Yeah, I think it's far. I worry too much. It's less likely to happen in near term. You have something that you request all the Kubernetes plugin to change, saying that your pod now needs a new API resource other than secret, other than config map. You have a new things. That will be
yeah, that'll be a pain. That'll be a problem. Well, cross our fingers that doesn't happen, I guess, for now. I mean, we'll know it well ahead of time if that's happening. We'll see the deprecations and we'll see all the alerts. I mean, it would break, if that ever happens, it breaks backwards compatibility, which means that all of Kubernetes is going to be in the same boat. And I'm pretty sure everybody's going to be pissed about that. And that won't actually end up happening.
Yeah. So given the current situation, so come back to our very beginning of the upgrade workflow. So we were thinking like, upgrade super first, and upgrade the syncer can, out of the tight loop, you can upgrade as what we did now. Our syncer version is already bumped to 120, right? I think you bumped to 120. And it was working on 118 super and 116 virtual, no problem. So it still works. So cool. Yeah. So then, but the holding distribution, so if you like to use the new API field, so you better upgrade super first, then you upgrade the virtual. Virtual doesn't have to be, you can do rolling kind of thing, right? You don't have to upgrade all virtual at the same time. You can just upgrade 10% today, 10% tomorrow kind of thing, doing the kind of.
Wait, can you do that one more time for me? So you are, or I'll just repeat it back and make sure I heard you right. You have tenant control plane. So what is user facing is 116. You are running the current syncer, which is 120, and you're then also running 118 as the super clusters.
I think it should work.
Wow, that's a huge version skew. That's awesome that works.
I
Sweet.
did double check that one. I'm pretty sure 120 and 118. I'm not very sure of 116 virtual. That I'm not.
Yeah,
very sure.
the 116 there is what makes me surprised, because that's what 4 versions that's out of the SKU, but that's amazing that actually works.
But think about it. Our current use cases, our users of VC just use a very small subset of the features.
Sure.
Because it's not open to public, as I explained.
Right.
It's
Yeah.
open to your production team, right? So they just, for example, if they just run the job, so the job API is kind of pretty fixed, and they don't use all the new fancy features like
Sure.
product spreader. They don't care about product spreader anyway.
Oh, that makes a lot of sense. Okay. Yeah, that makes a
If
lot
you
of sense.
expose to end users, that'd be a problem, because end user can do everything. Like you did, you guys exposed to end users, so
Yeah, we get to deal with all the pains that you guys get to avoid. Okay, that's cool. That makes a lot more sense. Yeah, that makes a lot of sense. Cool. Yeah, the upgrade story, that seems like that makes the most sense to me. I would love to hear.
Are you guys doing upgrade every 3 months? The Kubernetes upgrade cycle is pretty short, in my opinion.
Yeah, I mean, we're getting longer now that it's 3 releases instead of 4. We're trying to follow as close as we possibly can. I don't know at the top of my head what we're running everywhere. But in essence, you'll notice that I'm trying to keep the syncer up to date as much as I possibly can. A lot of that has to do with
the whole problem is the virtual cluster making the cluster number much higher than super as before.
Yeah, absolutely.
1 or 2 times of magnitude higher, because supposedly, right, one super now can support hundreds, but you have hundreds of which tenant control plane needs to be upgraded.
Right.
But luckily, it's like pod upgrade, and most likely it's like pod upgrade is because we are using pod based. So we only need to worry about for LCD part. So but that can be different, because you can have a plugin, because LCD most likely won't be sitting in the pods.
Right.
We should have a persistent story anyway.
Right. Yeah, we'll need to follow along with the V1 Alpha 5 feature for etcd provider and see if we can integrate with that early, and not have to deal with it later as well. Something for folks to pay attention to. There's an open issue as well in the CapN repo for this.
But I think in the CapN, I don't know, but we should think about it. So I don't have that in mind, because for the CapN, next step, if the whole provision workflow getting mature, we should think about the upgrade workflow. Especially think about it, is there anything that our controller should help, or anything script or anything that can help to upgrade the tens of the VC KPN control plane.
Like, how could you do a rolling upgrade across that and not have to individually do each one, or not have to like think that you're gonna upgrade one single component and it goes and cycles through every single piece? Yeah,
I think that would be very useful, in the sense that you don't do individual upgrade. You will have a whatever controller or kind of script kind of tools that help you to upgrade everything. But you can specify how you want to do that, right? 10% today, 10% tomorrow. You don't want to stop the service. That's a key.
Yeah, that's a really good idea.
Yeah, because
cool.
Nobody, I mean, in the upstream, this is not going to. Most upstream project doesn't cover this, because they saw this job to SRE. They will handle this. But in fact, that's very painful things, and a lot. If you don't do it right, it will be very time consuming.
Yeah. I mean, there's definitely a lot of prior art within the CAPI space. So we should take a look at what everybody's doing for these kind of strategies, and see what KCP is actually doing to implement upgrades of their control planes. I mean, they treat it at a declarative level. So a version is on the cluster, is typically on the cluster field, or cluster CR. And so you could take in the Kubernetes cluster version from there and then do whatever upgrades we want, which would mean that an SRE person in that world of running these systems would go through and update every single CR, which does, at least it pushes it out of this orchestration, which is kind of nice, and it allows anybody to implement it in the way that they want. If you wanted to go and grab every CR, and when you release a new version, just do a mass update to every single cluster and it just cycles them, that works. If you want to do individual, it works as well. Kind of, it makes it flexible enough for you to build on top of it.
Yeah, so the problem I was worried is about, so currently KPN, so each component they have their own workload, like stable set, right?
Yep.
So, but this make it a little bit hard to, let's say, just upgrade version for a particular tenant.
Kind of. Right now, we could technically do it. I think we can probably do a pretty. Chow, correct me if I'm wrong here, or Charles, correct me if I'm wrong here. Like, technically, from the the stateful set, if we had a field in each one of the CRs that had an image version, we'd be at least able to inject in a new image version into it. And then we probably need something at the flag level that would allow you to mutate that. Now, this is where we're getting into the place where it might be nice to add a patch field so that you could just patch the object, the underlying stateful set object, through the top level nested component CR. But I think once you did that, you could go and add or update any fields you needed to support the new version. Say, for instance, the config runtime flag needed to get added, and so you add that through a patch when you updated the image version. You could technically do it,
Yes.
and you would do it at each level. Yeah.
Yeah, right. So since we are using stateful set, we can always update the image and activate the reconcile loop. Yeah, but there are a lot of things we need to also figure out, because we need to say, if we allow user to update the image, we also allow user to update the arguments or other things inside the components templates. Yeah, that's something we need to figure out.
Cool. All right. Hey, folks, it is 11 a.m. I do have to run to another meeting. I wanted to throw one big call out there and just say the new CAPN integration. I wanted to do some testing last weekend, and I thought this was pretty awesome, but I was able to bring up an off-the-shelf VC setup, the same way that we have it set up, exactly like what I think you're doing internally with you're using the all Yun control planes. I was able to do that because of the new CAPI implementation. I was able to use Kappa, so Cluster API provider AWS, to create a control plane with 0 nodes, create another scheduling cluster with multiple nodes, wire it up using the cluster CR with the virtual cluster labels, and everything just worked. So separate from this isn't what we're doing internally, but I wanted to test the thing that we were talking about doing. How could you bring up a cluster, or how could you bring up and use CAPI and use CAPI's control planes and a scheduling domain provisioned by CAPI to automatically wire the two together with the virtual cluster components. So, and it just worked flawlessly, which is super cool. So I'll put together the demo again to show everybody what it looks like, because I thought that was pretty awesome.
Yeah,
so.
I think our internal guys has tried that as well. So
nice.
So they want to try that. So they want to bring up super in the ACK and bring the virtual from ACK as well, and it just works. Yeah,
it's so awesome. I'm so stoked because it disconnected what we were talking about, scheduling, or sorry, the connecting into virtual cluster from provisioning, and it was just seamless. But anyways, I got to stop the recording because I have to run to another meeting. Thanks everybody for chatting. It was fantastic. Again, it'll be posted to YouTube in about, I don't know, half an hour to an hour. See y'all next week.
See you. Bye-bye.
Bye.